Hello, class. Coming to you virtually today. Hope everyone is well. We will be getting back into Module 2 today, continuing with the second part of 2.1. If you'll recall, we introduced in 2.1 the first part, polynomials and their graphs and some different characteristics. Today, we're going to look at the second half of this section, and I am going to share my screen and get started. Okay, so I do want to go back just briefly and look at that last bit of information that was in the first part of 2.1. I do want to complete that, and then we'll get into the second part. If my video runs long, I'll make a second video, but I'll just determine that at the end. So let's look at the strategy for graphing. So here we are. I'm going to zoom in a bit. Here we are with, and I briefly went over this a little bit on Tuesday, but here we are just looking at some different characteristics, some different things that we studied in class: leading coefficient tests, finding x-intercepts, which is basically finding the zeros, determining the multiplicity, what's happening at those zeros. Then, turning that over, we will also find the y-intercept, and that is again where we let x equal 0. We compute the function by plugging in 0 wherever we see x. We can use symmetry to help us draw the graph. And then we, of course, also can, look at our calculator too. So we'll look at an example where we're kind of just following these different steps, these strategies to graph a function. So I'm going to go straight to a homework problem, but there are examples, or there is at least one example in the notes as well. Okay. Here is the homework 2.1. As you can recall, remember, we looked at quite a few in class. We're going to pick back up with number 8. This is number 8, if I'm not mistaken. Yes. So on this one, it says use the given function to complete parts A through E below. So the first part says use the leading coefficient test to determine the graph's end behavior. Now keep in mind, of course, you do have a calculator, okay? So we can look at the graph as well to see what's happening, okay? First off, this particular function has been factored, so I kind of suggest that you look at the graph, unless you want to multiply it through or multiply it out. Looking at the graph may not be a bad idea on this problem. So I'm going to plug it into my calculator just so that you can see what I mean here. But if you notice, this particular x is squared, and then you've got a binomial here that's squared. So if you think about it, if this was multiplied out and then you were to multiply whatever you got here to this, your highest degree should be a fourth power. So it should actually, the end behaviors should actually go in the same direction. Now, notice that this leading coefficient here, well, this constant factor here that's pulled out because it's not multiplied out, remember it's in its factored form, is negative. So what's going to happen here, let's go ahead and say the degree of this polynomial is 4, and the leading coefficient is negative. So this particular polynomial, its end behavior, it will fall left and right. It will fall to the left and it will fall to the right. And that again is because you've got an even power, the degree is even, but then in addition, the coefficient is negative though. So the graph will fall to the left and fall to the right. But let's go ahead and just take a quick look. Don't forget, you know, you do have the luxury of having technology. So I'm going to plug it in, -4, and then I've got in parentheses, x minus 2, and I'm going to square that. And then I've got another set of parentheses. Let me come down at the parenthesis, at the exponent. Another set of parentheses, x squared, and then -9, okay? And I'm going to hit graph. And I'm going to see if we can see anything that's happening here. So it might be helpful to kind of zoom out. I suggest maybe going for maybe 25 by 25. So let's adjust our window and see if that helps. Right now we're at, and actually the X is fine because the X is a 10 by 10. But the Y is what I'm not really getting a very good picture of. I'm seeing quite a bit of the graph, but I'd like to see more. So I'm going to adjust my window. Instead of a 10 by 10 on the Y, let's even try just 20, -20 to +20, and see if that's enough to maybe get us a better view. And we do see more. If you want to zoom out even more, you can. Let's go maybe 30, I guess. 30 by 30 to kind of get a better view. I was hoping to see more of the top so that you could know for sure that it is pointed downward. I was hoping to see more of the top there. I'm going to try it again. Let's go 40. Let's leave that 30 though. Let's go 40. Still not really seeing everything I wanted to see, but that's okay. I really wanted to see where the polynomial started at the top there. That must be, those numbers must get really big here. They do. So that's okay though, but you can see that it is downward. What's happening here is it's increasing and then it's kind of, I guess, leveling off here, curving, and then coming back down, okay? So we do have a in behavior where it's falling to the left and falling to the right. Now, as for the x-intercepts, that is where you would solve by placing the factors equal to 0. So it's already in its factored form. So you would have -4, which is a factor, equal to 0. But because that's not true, you're going to toss that one out. And then you'd have x minus 2 squared equals 0. And then you'd also have x squared minus 9 equal to 0, okay? So we've got, notice an exponent of 2 here. So we've got x minus 2 that we're going to solve, which is just x equals a +2 with a multiplicity of 2. Okay, so that's one solution. And I'm going to show you the calculator again in a minute, and you'll see that we can tell that it crosses at 2 on the graph. This one, I'm going to use the square root property, where I'm going to take the 9. I'm going to kind of put an arrow here to kind of scoot it over a bit. I'm going to take the 9 and move it over to the other side. So that gives me x squared equals 9. And then I'm going to take the square root. So I'll have x equals a plus or minus 3. When you take the square root of 9, you get plus or minus 3. So I have 3 x-intercepts. So I technically have 3 solutions. I have 2, I have -3, and I have +3. And we're going to separate these with commas. No particular order, but I'm going to put them in, I suppose, descending order. Or no, let's go ascending order. Let's start with the smallest. So -3, +2, and then +3. Then it says, at which 0 does the graph of the function cross the x-axis? Well, it crosses the x-axis. Let's take a look. It crosses the x-axis here at -3, and then over here at +3, okay? So the graph crosses the x-axis. I'm going to select A at -3 and +3, okay? Crosses straight through. But then it touches and turns when you have an even multiplicity. Remember, it touches and turns at positive 2. And you can tell that from the graph also, right there. Touches and turns at 2. So right here, I will select A, and it says the graph touches the x-axis and turns around at the 0, 2. Okay? And again, I did solve it traditionally using our algebra techniques, but I also used the graph to help me to kind of just verify that. Then on part C, it says find the y-intercept by computing f at 0. So f at 0 is simply where you take the function and you replace x with 0 wherever you see x in the function. So evaluating f at 0 would be -4 parentheses 0 minus 2 squared, another pair of parentheses 0 squared minus 9. So I left it in the original form. Okay, I'm gonna scoot it down here just for a minute so you can see. I left it in the original form and I just replaced the x with 0 wherever I saw it. Okay. So remember, when I'm working through these on this video, you already have this copy. I gave this to everyone in class on Tuesday. So this video is to help you kind of follow along to be able to do the homework in Pearson. Okay. So when I plug in the 0, right here, I've got -4 still. Inside the parentheses, I've got -2 squared because that's 0 minus, uh-oh, did my screen freeze up? It sure did. Okay. So let me stop sharing for a minute and share again. Sometimes technology wants to act up on us, doesn't it? Okay. And it's still frozen. Okay. Try that again. Sorry, you guys. Let me try this again here. Share my screen. I may have to close. Isn't that something here? I tell you what, technology. It's okay though. Let me get back in it. Okay, now we're ready. All right, and I'm going to share my screen again. Okay, there we go. So I'm back. Sorry about that. Okay, so looking at this part, I've got, and this is going to be times, it's 0 squared, which is just 0 minus 9, so that's a -9. Okay. Then we've got to just kind of simplify that, clean all that up. So we got -4 times -2 squared, and I could actually put that straight in my calculator if I wanted to, literally. -4 parentheses -2 squared times -9. Okay, and we'll press enter there. We get 144 as the y-intercept. Okay. All right, this next part, part D, is asking us to determine the symmetry of the graph. So here in this case, so I'm gonna just put 144 here. If we just whip that in the calculator there. So here on this part, to determine what kind of symmetry we have, remember we evaluate the function at -x to see what we get. If we get opposite, if we get everything like a sign change on everything, then what that means is that we would have y-axis symmetry. We would have y-axis symmetry. If we plug in -x and we get back the original function, then we have y-axis symmetry. If we plug in -x for every x and we get the opposite of the function, meaning every sign gets changed, then that means we have origin symmetry. Okay, so what we're going to do is we're going to evaluate the function at -x and see what happens. Okay, if we do not get either of those, then we'll just say neither. So f at -x. So I'm going to take the function and I'm going to replace each x with -x. So I have -4 times -x minus 2 squared times -x squared minus 9. Okay? So I'm going to clean this up wherever I can. I've got -4. In here, I still just have -x minus 2. There's nothing I can really do there because the whole binomial is supposed to be squared. Now, if it was supposed to be like just the x part squared, then that negative will go away. But this is a whole binomial squared, so I can't really do anything there. Now, over here, though, I can. This is -x squared, so that would become just x squared and then minus 9. But unfortunately, that is not the exact same. That term right there is still negative when originally it was positive. So that means I do not have the original function back. Okay, I did not get the original f of x back. And also, since every sign did not change, everything did not change, notice that that was still x squared, the same as the original function. I did not get an opposite of the original function, so I do not have origin symmetry either. So I actually have neither in this case. Okay? So I actually have neither. And then at this point, remember you got your calculator. So you can literally look at the graph on the calculator and see that it would match A. It's just I need to make my upper, I guess my upper Y coordinate or my Y max and min a bit larger. I believe they've got 351. Wow. So let's say I make it that big so we can actually see it on our calculator. I did not think it would need to be that big, but apparently so. And then we'll go, do I really? Oh, you know what? Yeah, I'll go ahead. I was about to say I don't really need that to be all the way down, but I'll keep that. And then now we see the graph. There we go. So wow, it needed to be very large. So it is A. Okay. But even if you did not zoom out enough on the graph originally, it's multiple choice, so you can see what numbers you needed to zoom out to see it. But even if I had left it alone, I think I still would have been able to determine that it had to be A. Okay. And I just wanted to show you that because it just took all those different items that we were looking at on Tuesday and put them all together in one problem. Okay. Now we're going to look at the second part of the topics of the discussion. And I'm going to get the notes out. Second part. And this is, again, still 2.1, but it's part 2. And this is where we're looking at dividing polynomials. We're going to look at 2 methods, long division and synthetic. And then we also have the remainder and factor theorems. So just a few objectives using long division, using synthetic division. We'll evaluate using the remainder theorem, and we'll use the factor theorem to solve. So long division. We've got some basic steps for long division, which are similar to our long division steps for arithmetic. You will have your dividend under the rooftop. I guess you can call this a rooftop. Here would be your dividend. Here would be your divisor out here that you're dividing by. Divisor, divise. I can't spell, y'all. And here would be the answer, which is called the quotient. Okay, so I'm going to write down the steps as I go through them when we're working problems. But the first step, after you arrange them, after you arrange the powers of your dividend and divisor in descending order, if they're not already, technically the first step is to divide. You'll divide the first term of the dividend by the first term of the divisor. And the result of that answer will be the first term that goes up here, the first term of the quotient. Then you'll take that answer that you just found from that first step and you'll multiply it by the entire divisor, by the whole divisor. And then you'll take that product and you'll write it underneath the dividend so that the like terms line up so that you'll then be able to subtract that product from the dividend. Once you get that difference, you'll bring down the next term and then you'll start over with that new expression that you're going to form and just repeat that same process. Okay, that would be long division. So I'm going to start off with looking at long division. I'm going to begin with homework problem. That is, let's see here. It looks like number 11 and number 12 actually are asking us to complete or fill in the blank to kind of complete the problem, so to speak. We're not necessarily computing the entire doing the complete long division problem. So it might be helpful to actually see a problem completed, and then you'll see where these steps are coming from. So I hate that those are first because I don't want to start with those first. I actually want to start with number 13 first, and then number 14, and then we'll go back to those. Because it's easier to see the steps worked out, you working them out, than to see a bunch of stuff on the paper and not know where they came from. It's a little bit, to me, I find it easier to actually see the steps in the process of them, okay, in the process of doing it. So I'm going to do number 13. So in the following problem, it says divide using long division, state the quotient and the remainder. So the first thing we do, understand that this is the dividend, this is the divisor. It is x squared plus 8x plus 15 divided by x plus 3. So under my housetop, I will have my dividend in descending order, and it already is because it's going from x squared to x and then down to the constant. And then I'll have x plus 3 out here, okay? So we've got the first term. We're going to divide it by the first term. So step number 1, divide first term by first term. Okay? So first term of our dividend by the first term of our divisor. So x squared divided by x. Okay? Now what's going to happen? Well, x squared means I have 2 of them. So I'm taking away 1 of them from the top because I'm dividing by 1. So x squared divided by x is going to leave me with just an x. In other words, this x is going to cancel out one of those on the top. That x, that answer, goes above, is the first term of the quotient. Remember, the quotient is the answer that sits up here. It goes above the housetop, sits on the roof here, right up above the matching term. It's like term. So I put it right up above the x term there. Okay? Step number 2, I take the answer from step 1 and multiply by the entire divisor. Okay? So I'm going to take that x that I just had from this step 1, and I'm going to multiply it by the entire divisor by x plus 3. So when I multiply, notice that I did put that in parentheses because I have to use the distributive property. So you've got x here that you're going to multiply with, and then x times the 3 as well. So x times x gives you back the x squared, and x times 3 gives you plus 3x. Okay? We're going to take that answer and we're going to write it right below x squared plus 8x. Because on step number 3, we're going to subtract the product from step 2. Let me put step here. We're going to subtract the product from step 2 from the dividend. I'm going to write it right underneath the terms that it matches. So x squared plus 3x. And we haven't subtracted it until we put that in parentheses and put a minus out front there. That's how we know we're subtracting. Okay? So when I get ready to actually do the subtraction, I'm actually taking the sign. I'm actually going to be taking that sign through. So I'm going to carry, it's almost like an imaginary -1 there. So I'm taking that sign through. This becomes minus and this becomes minus. It changes the signs. So basically it's gone out front, and you almost just have to ignore the parentheses and just now subtract. So x squared minus x squared cancels. 8x minus 3x, that is 5x. Okay? So that was your end goal right there, was to get the x squared to go away. Then when you subtract it here, 8x minus 3x, that left you with 5x. And then your fourth step is to bring down next term. Okay, so that's where I bring down the plus 15. And then when I bring down my next term there, I start all the way over again. This is now my new starting point. So I start over with these same steps, but this is my new dividend now. So basically what I did before right here, I ignore and I start right here. Step number 1 again. Divide first term. I'm going to use a shortened abbreviation for first. Divided by first term. So that will be the first term here, this 5x, divided by the first term here of the divisor. Okay, so 5x divided by x, the x is canceled, that leaves me with 5. That is now my second term of my quotient, of my answer. And it's a positive 5, so when I write it up here, I write it as plus 5. Okay. Now I take, for step number 2, I take that answer, because remember, you're done up here. You ignore what you did before. You take the answer, we'll use this answer from step 1 and multiply by the entire divisor. Okay, so I'm taking now that 5 and I'm going to multiply it by the entire divisor here, by the x plus 3. Okay, so I distribute, because I'm multiplying 5 by a binomial, so I have to distribute the 5. So that becomes 5x plus 15. Okay, and I write that answer on step 3. I actually write that answer right underneath this dividend because I'm going to subtract. So step number 3, I'm going to subtract the product that I just found, because when I multiplied through that 5, that became a product. I'm going to zoom out a bit here because I'm running out of room, camera room. So I'm going to subtract that product from step 2 from the dividend. Okay, so I'm taking this 5x and I'm writing it right underneath its like terms. I haven't subtracted it until I put it in parentheses and I show that I'm subtracting that whole thing. I show it with a minus out front. Now I take the minus through, because you imagine like there's a -1 there. You take that minus through, which is going to change this sign and this sign. And now you carried it through. So your 5x minus 5x is canceled or goes away, 0. 15 minus 15, that's 0 as well. This is your remainder. You had no remainder. You had a 0 remainder. So your answer, when you get ready to write that in or type that in, it will be right here. This is where your answer, your quotient will be, x plus 5. And we express the remainder as basically a fraction of the divisor. So in this case, we have no remainder, it's 0. So we would have 0 over x plus 3. If there was an actual remainder, it would be whatever it is over x plus 3. Anytime you have a remainder, you express it as a fraction. Think about how we did with arithmetic numbers. If I had a remainder, I would express it as a fraction or a portion of my dividend, of my divisor. So my quotient plus my remainder over my divisor. So x plus 5 plus a remainder of 0. Okay? I'm going to do another one. We'll walk back through it. Okay? So let's look at number 14 as well. This one is a bit longer, but that's not a bad thing. It'll give us a chance to see the process repeatedly a few times, I think. So I'm going to do number 14. First thing I'm going to do, notice that it does say use long division. So the first thing I'm going to do is write it using my housetop. I have to write it using the long division form. So this is my dividend and this is my divisor. Okay. So 3x cubed, making sure it's in descending order, minus 8x squared plus 5x plus 4. And it is in descending order because it went from exponent of 3 to 1 and then 0, just a constant. So 3x squared plus x plus 9 is my divisor. All right. So my first step is I'm going to divide the first term of my dividend by the first term of my divisor. So divide first by first. First term divided by first term. So 3x cubed divided by 3x squared. Okay? That's going to give me just x. The 3's cancel. X cubed divided by x squared leaves me with just an x. So I take that answer. That answer is the first term of my quotient, of my answer. So I put it right up above its matching term. It's an x, so it goes up above the x term. Then step number 2, I'm going to multiply the answer from step 1 by the entire divisor. Okay, so my x would then be multiplied by this whole thing, 3x squared plus x plus 9. And I'm going to use the distributive property. Have to do that, okay, in order to correctly multiply, use the distributive property. That's going to give me back my 3x squared, okay? X times 3x squared, sorry. That's going to give me back my 3x cubed because it's 3x squared times x, okay? I'm going to get that back. Then the second term is going to be x squared because it's x times x. And then my third term is going to be plus 9x, okay? Step number 3, I'm going to take the answer, the product that I just found, subtract the product that we just found from step 2, subtract the product from step 2 from the dividend. So I'm going to take this product and put it right underneath the terms that it matches. 3x cubed plus x squared plus 9x. And I'm going to subtract it, but I haven't subtracted it until I put it in parentheses and I put a minus out front. Okay? That's when I know that I'm subtracting. Now, to subtract, imagine again that there's a -1 there because you're going to take it through. That makes this negative, and this negative. And so when you take it through, it's gone, and you can ignore the parentheses now and just subtract. So 3x cubed minus 3x cubed, that goes away. Negative 8x squared minus x squared gives you a negative 9x squared. And then a positive 5 and a negative 9 is a minus 4x. Okay? And then we're going to bring down our next term. Step number 4, bring down next term. Okay? Bring down our next term. So at that point, I start all over again. And this is now my new starting point. This right here is now my new starting point. So divide first term right here by first term here. When I bring down the next term, this is now my new starting point. So I ignore what I did before, okay? So my new starting point, I'm going to divide negative 9x squared by the first term of our divisor, by 3x squared. Now, what does that give me? Well, the x squareds cancel. Negative 9 divided by 3 gives me a -3. And so that gets written up above as the second term of my quotient, the second term of my answer. And it's a -3, so it's going to be written as a -3. Okay? Step number 2, I'm going to multiply this answer right here that I just found. Because remember, when you start over, you ignore what you did before. This is your new starting point. So you're going to multiply the answer from step 1 by the entire divisor. So I'm going to take that negative 3. Let me scoot this up a bit here. I'm going to take that negative 3, and I'm going to multiply it by 3x squared plus x plus 9. Okay? And so, of course, because I'm multiplying over several terms, I have to use the distributive property. So that becomes a negative 9x squared, a minus 3x, and then a minus 27. I multiply by negative 3, so it changed every sign. Negative 9x squared, minus 3x, minus 27. And then I'm going to take that answer and I'm going to write it right underneath the matching terms, the like terms of the dividend, because I'm going to subtract. So I'm going to subtract the product from step 2. And of course, we're talking about this step 2, okay? Because remember, whatever we did before is gone. We're ignoring that. We're talking about this step 2. So we're going to subtract the product from step 2, this right here, from the dividend. Okay? So I'm going to take that and I'm going to put it right underneath here, 9x squared minus 3x minus 27. And I haven't subtracted it until I put it in parentheses and I put a minus out front. Okay, make sure you remember to do that. If you do not put the minus out front, you have not subtracted it. Now you're going to take that minus through, which is then going to change this sign to a plus, this sign to a plus, and this sign to a plus. So you took it through, so it's gone out there. And now you're able to subtract. So a negative 9x squared, now plus 9x squared goes away. A negative 4x plus 3x is a negative x. And a positive 4 plus 27 is what? 31 plus 31. So there is nothing else that you can do now. This is your remainder, and I'm going to explain why. Even though you still have a variable in it, this is your remainder because your remainder is now a lower power than your divisor was. So because you cannot divide x by x squared, then this whole expression is just your simple remainder now. So here's how we express that answer. We put our quotient in the first box, which is the answer here, which is x minus 3. And then up above the divisor, we put that remainder, which is negative x plus 31. Okay? And that's long division. I'm going to come back before I do synthetic division. I'm going to come back with another example. I'm going to stop this video and make a second video. It's running a bit long. And I'm going to shut it off and then I'll come back with video number 2. Thank you. See y'all soon.